This is Mrs. Cantz. Today you guys have a lab that is due on the natural selection process. And I wanted to give you guys a little bit of tutorial on how to make that happen. Make you guys still have to do the project, be able to actually go through the steps. However, give you some hints on how to make this happen. So right now, I'm on my homepage, and in the content, looking at the Lab 2.09 laboratory process of natural selection. There's a few things that you're going to want to print off and read before you even start this lab. So first things first, this lesson introduction. Please make sure that you read through this introduction. It's only 3 slides, so pretty short, but you're going to want to know this information. I'm going to kind of skip through this, but what you're going to want to print off first, and I suggest printing it off and not just having it up, but this student guide right here, lesson 9, if you don't have this and you don't have it open and you are not following the instructions, you are going to not succeed at this lab because it is based off of all of these step-by-step instructions. So you are going to want this in front of you. It's going to share with you what you need as well. It says you need dice, 6-sided dice, a marker. I used a pen, so you don't have to have a marker. A pen, pencil, any writing utensil will work. A ruler, so I have my ruler here. If you don't have a ruler, you can actually look one up online. There are rulers online that you can use, and it'll probably make it a lot more difficult unless if you have an actual ruler or a measuring tape. However, there are other resources. If you don't have dice, there is also a website, random.org, and you can find dice there as well. So if you don't have any of this the ruler and the dice, there's resources online you can get. Construction paper, probably don't have to have actual construction paper. You could probably just use a piece of paper, whether it's line paper or printer paper. Scissors and tape. So make sure you have those. And then make sure that you read through all of this information. I'm going to go back to this. And you're going to read through the laboratory and this learn process before you even start the lab. So you want that printed off. However, don't even look at it. Maybe read through it a little bit, but don't start until you read through the laboratory and that learn aspect. And then we've changed the assignment a little bit, so you do not have an actual lab you are filling out. What you're doing is writing a conclusion. So right here is where you will find that conclusion. And it's going to be you answering some questions. So before you start your experiment, you have a question that you have to answer. You're going to be writing a hypothesis. And then after you do the experiment, then you will be writing a conclusion off of your data that you collected and what types of things happened in this experiment as far as the natural selection. So you're also going to want to maybe print this off as well, so that you have it in front of you what you need to be answering as you're going through. But before you even start, there's this part that says, before starting the experiment, write a hypothesis on which lizard parent, long or short legs, will travel the greater distance. Well, if that makes no sense to you, that means you probably didn't read the lab first. So go back to the lab, read it first, answer that question. Then you can complete your experiment And after your experiment is complete, then you can answer the rest of those questions. The lab conclusion does need to be in paragraph form, which means complete sentences. You should have good grammar. Make sure there's punctuation, all that kind of stuff. So please make sure that is all set. I'm going to show you a few tips on how to complete this lab, though. Let's start here. Parent 1 generation. First of all, you need to construct your lizards. So what they have you do, they're going to have you take construction paper, and you're going to have to measure out that piece of paper to specific sizes. So the lizard with short legs, you're going to cut a strip of paper that is 4 centimeters by 10 centimeters. If you notice on this, the 4 centimeters is going to be the width, and the 10 centimeters is going to be the length. And then it asks you to roll it up and tape it together so it looks like this. It's very small. I struggled with this one. And then it asks you to, with a black marker, I use just a black pen, you're going to draw a line inside the loop. For this one, I just drew a line, and then I realized it was probably easier if I used that edge of the piece of paper to draw a straight line. So that's a little tip for you. If you use that edge of the inside of the paper as your straight line, that would help as well. So parent 1 is already done. That's kind of what it's going to look like. Yours is probably going to look a little different. I struggled with this one. Hopefully you guys do much better at making your lizards than I did. And then for the second one, it says that you're going to cut the strip of paper for 4 centimeters by 20 centimeters. So 4 centimeters in width, 20 centimeters in length. Same thing. You're going to fold it over. You're going to tape it. And then this one, I figured, hey, how about I use that line? So I drew a line, which you guys probably can't see very well. Drew a line in the center. You're going to be using that black line for your experiment. So then, after that is, you have your 2 lizards all connected. You're going to move down to the second part, part B. Part B, this is where you're going to use your dice. So your dice, it says examine the die. Each side has a specific number of dots, 1 through 6. For generation 1, on your student guide, you'll notice charts. Those charts will show you F1 generation, F2 generation, F3 generation for short legs, and you'll have one for long legs as well. So what they're asking you to do is roll that die 6 times. Dots 1 through 3 are representing the short legs, and then dots 4 through 6 are representing the long legs offspring. So we're rolling those dice 6 times. I'm going to go ahead and roll the dice, and I'm just going to write down how many short, how many long. So let's go ahead and roll. I have a 5, and that would be, of course, I don't have a pen out here because why would I do that? So 5 would be my long legs. Roll it again, another 5. Again, long legs, so I'd have 2 long legs. This die is not very random, I don't think. That is also long legs, so I would call that a long-legged. 4 gives me also long legs. That's 4 long legs, no short legs. 6 is also long legs, and 1 gives me one short leg. So I have 5 long legs, 1 short leg. I'm going to grab my pen over here. So I write that down. And then I'm going to take that information, go back to my student guide, and it says we're going to see how far those parents are going to be traveling. So we're going to find a nice clear space. You can see that I have my desk here. I'm going to make it really awkward for you guys and try and make this so that you guys can see me and what's going on. And so it asks you to find a clear place. You're going to place a piece of tape on one end of the place. So I'm just going to place we'll put it here so you guys can see what I'm doing. And I'm just going to mark, just because I want to be able to see where I want to start. So I'm going to mark a little black dot. That's where I'm going to start. And then we are going to start to do our experiment. It says, as shown in the illustration below, place the parent 1 model on the tape marking. So parent 1 is my short leg guy. Make sure the black line is at the bottom of the loop. So I'm going to set that right there at my tape. And roll the model 1 full turn for each individual with short legs that was born into the F1 generation. For example, if 5 short-legged lizards were born, I'm going to roll this 5 complete times. That's why you have that black line, so you know where a full turn is. I only had 1 short, so all I'm going to do is I'm going to roll it 1 time, and I'm going to take another piece of paper, or piece of tape, and mark where I stopped. So here is where I stopped, and now I am going to measure, okay? So I will be measuring this now. So from 1 black line, and they want this all in centimeters, so make sure you're using centimeters for this. And I'm going to measure this, and it is 10.5 centimeters. So on your chart, F1 generation, parent 1 for my short legs. I put, technically my first time I did 3, but this time I did 1, and I'm just going to put how far that 1 parent traveled, which was, I don't remember, I think it was 10.5. Let's try that. Yep, 10.5 centimeters. And then I'm going to do the same thing with my long legs. My long legs, though, I had 5 offspring. So I'm going to start here. I'm going to roll it 5 complete times. I will measure it out, write that down, and I'm going to do that 2 more times. And so it tells you, again, part C, you're going to have that, you're going to do it again. However, look at the difference between what those dots on the die actually represent. 1 and 2 are for short legs. 3 through 6 are for long legs. So it's going to change. Part D, you're doing the same thing. However, again, the dots change and represent us different things. So please make sure that you are reading very carefully on what represents what. I'm going to come up off my knees because it's hurting me. And so once you have that, there's some questions for you to answer. These questions are going to help you in writing that conclusion. So they're pretty simple questions. What was the total distance? So once you get all 3 generations, you're going to have a total distance. You add those all up, and you'll be able to get a specific number. What was the total distance the long legs traveled? Total number of each offspring, and then which trait had the greatest chance of passing down those traits. You can make those, answer those questions, and then it will help you write your conclusion. Once you have written your conclusion, remember that's off of this piece of paper here. It is not off the lab report.